Hey there, this video will be a synopsis of ionic compounds. What you're looking at here is a model of how ionic compounds sort of form. And again, it's a model. It's symbolic of how ionic compounds work. What is an ionic compound? Well, you'll notice here that an ionic compound is composed of what's called a cation and an anion. With the cation being a positive ion and the anion being a negative ion. The compound forms because they're oppositely charged, the cation and the anion, and they stick together by electromagnetism. Opposites attract. So what we really have here is atoms of metal and atoms of non-metal. What you find is that the non-metal steals electrons from the metal. Because the non-metal is stealing electrons, it becomes negative, hence an anion. Because the metal is losing electrons, it becomes positive, and hence the cation. That creates the opposite charges, which causes it to stick together. Probably the most famous example of an ionic compound is sodium chloride, also known as table salt. Its formula is NaCl. The Na for sodium, the Cl for chlorine. Now, think about what I just said. In an ionic compound, the nonmetal takes electrons from the metal. That makes the nonmetal negative, it makes the metal positive. So what we have here, and we could symbolically represent this with a dot diagram. Here on the left, we have sodium and we have chlorine. Chlorine is able to pull in this valence electron from the sodium, and it kind of takes it as its own. Because it now has an extra electron, it's going to have an overall negative charge. Because sodium lost an electron, it's going to have an overall positive charge. And now, since they're oppositely charged, they can stick together, and they can form the structure that you saw at the opening, the alternating positive and negative ions, aka cations and anions. Now, there's a few things that we know about table salt, which is true for most ionic compounds. One is that it dissolves in water. Most ionic compounds will dissolve in water, and here's the big thing. Ionic compounds will conduct when dissolved. Didn't have room for it there. But you get the point. Two important properties of ionic compounds is that they dissolve in water and that they conduct when dissolved. In fact, we tend to call ionic compounds electrolytes for the fact that they conduct when dissolved in water. If you look on the back of a Gatorade bottle, you'll see ionic compounds written right into the ingredients list. Those electrolytes that they're advertising in your Gatorade are the same electrolytes that I'm talking about here. So lastly, how do you know when you have an ionic compound? Well, you're going to look for a number of things to be true. First off, you're going to look that you have a metal bonded to a non-metal, or metals and non-metals, depending on the subscript. So that's going to be one thing that tells you you're working with an ionic compound. If you're back in a lab, you can identify an ionic compound by the fact that they tend to dissolve in water. You could just get some water, sprinkle it in there, see if it dissolves. And if you have the equipment, you can test if it conducts when it's dissolved. That'll be another way to figure out if you're working with an ionic compound. Lastly, I would just reiterate the structure of ionic compounds, or at least how we symbolize the structure. And that's going to be represented by our alternating positive and negative ions. And again, these ions form because of electron exchange, trying to get 8 valence electrons, and the resulting situation is that you have cations and anions, which are equal and opposite in charge and stick together. So that was your brief synopsis of the basics of ionic compounds.